spinach and stuff like this is all organic oxalates. It's really a process of acidosis and what chemistry does in the acid medium. You can't get rid of all foods with oxalates in them. It's impossible. But you have to the medium that you present chemistry into dictates the effect of chemistry. When the kidneys get too acidic and stop filtering, or too acidic in the interstitially, you'll start seeing calcium bonding with several things, but particularly the oxalates, and so there's all that confusion of oxalates because, vegetables are full of oxalates. But you know what? It's the binding of chemistry through heat or acids that is the problem. Chemistry doesn't bind like that in base atmospheres, but when you have acidic atmospheres or acidic terrains, then you're going to see chemistry change its nature and the way it bonds and the way ionization takes place and the way these things, the way cell metabolism, the way cell absorption through the cell wall takes place. I get kidney stones from oxalates, which is a plant metabolite that is very high in, they have this whole thing because they see a constituent in a plant, you can't have it. Spinach and all the natural oxalates, hello, but how does the natural oxalate bind with calcium? Acid medium, perhaps? Yes, hello. You asked me about oxalic acid with beets and spinach, but that's raw. I mean, you're talking about in chemistry what happens in an acidic environment. Also when you cook it, there's a difference between cooked spinach and raw spinach and oxalates. And remember, cooking binds chemistry. Cooking is like acids. They bind. So this is why cooking augments chemistry big time. So yeah, I'd be careful with cooked foods like that, but raw foods like that, you're not going to have anything to worry about there. But the bottom line is, when things are raw, they don't create the problem as this counterpart cooked. So when I had kidney stones, we knew they were calcium oxalate stones, but I had been raised on dairies and highly acidics and high proteins. Yep.